The new Z22 SE. A four-cylinder Ecotec inline aluminium 16-valve 2.2-litre engine. It delivers its maximum power output of 108 kilowatts at 5,800 RPM and a maximum torque of 203 Newton meters at 4,000 RPM. The consistent use of special aluminium alloys produces a low weight of only 138 kilograms. Aluminium has been used for the cylinder head cover, cylinder head, cylinder block, cylinder block base plate, and the oil pan. The Z22 SE is used in the Astra G and Astra Coupe, in the Safira, in the Vectra B, and in the Speedster. The valves are actuated by two camshafts with needle-bearing roller cam followers, featuring maintenance-free hydraulic valve lifters. Two balancer shafts with cast iron counterweights rotate in opposite directions at twice the crankshaft speed for smooth engine running. Engine timing is effected via two maintenance-free timing chains. One timing chain drives the camshafts. The second chain drives the balancer shafts and coolant pump. Hydraulic chain tensioners ensure a maintenance-free precision chain drive. For the first time, the reference point for adjusting the timing on this engine is TDC of the fourth cylinder. For this purpose, the marking on the timing case must align with the notch on the torsional vibration damper. And the cams of the fourth cylinder must point upwards. The individual chain links are colour-coded only for adjusting the timing. This applies when fitting the chains for the first time. The coloured chain links have no significance once the engine has been cranked. Engine timing is checked using the special service tool KM6148. The DIS ignition module with integrated spark plug connectors will be familiar from other engines. To meet the stringent limit values of the Euro 4 exhaust emissions standard, the engine installation has been turned through 180 degrees. This means that the exhaust manifold lies protected behind the engine and the catalytic converters reach their operating temperature much quicker. The concept also features the additional use of a so-called starting catalytic converter, controlled via two oxygen sensors. The first oxygen sensor is for mixture control. The second sensor monitors the operation and efficiency of the main catalytic converter. This data, along with other data, is used by the onboard diagnosis system for diagnosis and controlling of the engine. The injectors are located beneath the fuel distributor pipe directly in the cylinder head. Part of the exhaust gas is fed through an integral duct in the cylinder head via the exhaust gas recirculation valve, and from there on through the exhaust gas recirculation pipe into the intake manifold. The intake manifold itself is made of plastic. The seal with the cylinder head consists of 4 rubber rings and a blue blow-by gasket at the center of the intake manifold. The engine control unit is flanged directly to the intake manifold. The two-part cylinder block comprises cylinder block and cylinder block base plate that virtually enclose the crankshaft. The two sections of the cylinder block can only be changed as a pair. The cylinder block is fitted with dry liners that cannot be renewed separately. Adjacent to the oil supply and coolant ducts, the ducts for crankcase ventilation are cast into the cylinder block. The single-piece aluminium oil pan has a rivet-mounted oil baffle plate with integrated oil intake pipe. Integrated into the oil pan is a dynamic oil level control. Special routing of the oil returns enhances oil separation. The oil pump is integrated into the timing case. A 7-notch sensor disc for the crankshaft pulse pickup is fitted to the crankshaft. Depending on the type of vehicle, oil changes are carried out after every 15,000 or 30,000 kilometres or once a year. Use special service tool KM6150 to renew the paper replacement cartridge. The oil filter housing features a bypass valve in the cover. A special feature of the coolant circuit is that when coolant is added, it first enters the radiator, from where it proceeds to the engine. As a result, the thermostat is located in the coolant circuit return line. On this engine, the coolant pump is exposed. Due to the modified flow in the cooling system, it must be ensured that the coolant hose is correctly positioned on the thermostat housing. Because of the special features of light alloy engines, a minimum quantity of coolant must always be present in the cooling system to prevent damage occurring. A new silicate-based coolant is used, which must not be mixed with other coolants. Coolant and water must be mixed at a ratio of at least 70 to 30. The Z22 SE features a maintenance-free ribbed V-belt with automatic tensioner. In addition to the familiar tools, operations on the Z22 SE require the use of 14 new special service tools. In general, all coolants, sealants and lubricants must be used as indicated in the service literature. All bolts must be tightened to the specified torque values and, if necessary, rotation angle. For improved demonstration of required service operations, the engine has been removed and fluids drained. First, turn the engine in the direction of engine rotation to the fourth cylinder TDC position. The marking on the timing case and the notch on the torsional vibration damper must be aligned. Remove the 4 bolts and take out the ignition module. Undo the 5 outer bolts on either side. And 4 inner bolts. And lift off the cylinder head cover. If the engine is positioned with the first cylinder at TDC and not the fourth cylinder, the engine must be turned a further 360 degrees at the torsional vibration damper. The cams of the fourth cylinder should now point upwards. Attach special service tool KM6148. The pins should now fit into the large bores in the camshaft sprockets. If this is the case, remove the camshaft timing chain tensioner. Remove the upper sliding rail. Remove the exhaust camshaft sprocket. To release the sprocket, counter-hold at the camshaft hexagon. Mark the running direction of the ribbed V-belt. Tension the tensioner using special service tool KM6151 and take off the ribbed V-belt. remove the tensioner. Using counter holder KM-J38122A and extension KM-956-1, release and remove the torsional vibration damper. Remove the cover screw. In order to take out the upper bolt of the camshaft timing chain guide rail. Remove the 10 timing case bolts. Because of its length when installed, removal of the coolant pump bolt will necessitate lowering the engine a little on some types of vehicle. Remove the timing case and gasket. Using a cloth, close off the aperture in the cylinder block base plate. Behind a cover in the timing case is the oil pump. Remove the camshaft timing chain guide rail. Followed by the camshaft timing chain tension rail. To release the camshaft sprocket, counter hold at the camshaft hexagon. Remove the timing chain together with the camshaft sprocket. First, loosen the 4 Torx bolts from the cylinder head. Then, in the sequence shown, release the 10 cylinder head hexagon bolts, initially by 90 degrees. The cylinder head must only be removed when the engine is cold, in other words, at room temperature. On the second round, unscrew the bolts by 180 degrees. Finally, lift off the cylinder head. Clean the sealing surfaces and bores. And check the cylinder block and cylinder head for plane surface.